Okay. Good, moving on. So I would like to look at 66. And 66 has a couple of questions. For each function, find the points on the graph at which the tangent line is horizontal. So before I copy 66, let's say I have this graph. Where do you think that the tangent line, I'm just going to put some points in there. Point A, point B, point C, point D, and one here, E. At which of these points, if you cannot see the graph, I will graph it again, a bigger graph. At which points do you think that the tangent is horizontal? It says for each function, find the points on the graph at which the tangent line is horizontal.
Would it be horizontal at A, B, and C?
Of course. At X, or maybe I should just say at A, B, and C, tangent is horizontal, a horizontal line. Of course, right here at the peak, right here at the bottom valley, if you want, right here at the peak, always. So if you see this is increasing and then decreasing, that's where the tangent will be horizontal. Decreasing and then increasing, that's where the tangent will be horizontal, and the same everywhere else. Good, so what do I have to determine first? Oh, I didn't copy the function, sorry. 66 was y equals 3x squared minus 5x and plus 4. So what do I have to do first? They're asking me to determine where is the tangent horizontal.
Aren't those vertices like A, B, and C?
They are max min. But
okay.
But what do I know? What's the connection between so how do I determine the points where the tangent is horizontal? So when a line is horizontal, what is its slope? First of all, let's discuss that.
0?
Yes. What do we know so far from this course that gives us the slope of the tangent line? How can I determine the slope of the tangent line from this course? What do we know?
The limit to 0 would always give us, or the derivative. Right?
Exactly. Exactly. So I have to determine the derivative. So let's determine the derivative. Can anyone quickly give us the derivative for this function?
6x.
Yes.
Minus 5.
That's it. So now I'm going to set it equal to 0 because I am told the tangent is horizontal, which means the slope is 0. And this is the slope. So when I set 6x minus 5 equal to 0, I move 5 and divide by 6, right? So I get 5/6. At this point, it's not a point yet, but at this x value, it's guaranteed that the slope is 0 because the tangent was set equal to 0 to get this. So I'm going to call this point P. So I have the x coordinate, but how do I determine the y coordinate? Because we are asked to find the point. I cannot just give the x. I also have to determine the y.
Set the x to 0?
So if I say this is a function, and I'm telling you x is 5, how do you determine the y coordinate for that point? Whatever.
You got to put it back into the original function.
Of course. Of course, you cannot just guess and say, oh, let's plug in something else, right? So this must be f of 5/6. If x is 5/6, the y coordinate of the point has to be the function value at 5/6. Is that clear for everyone? This is very important. Is that a yes or a no? Do we understand what's
Got
happening?
it.
Yes? Everyone?
Yes.
So let's find f of, so y or f is the same thing. That's the problem with y. I cannot write f of this. So that's why I prefer f of x versus y. So this is f of 5/6. So 3 times 5 over 6, everything squared, minus 5 times 5 over 6, and plus 4. So obviously, I have to square first. So this is 25 over 36. This is 25 over 6, and this is 4. And I will simplify by 3, of course, and I get 12. Can anyone give us now the least common denominator? Good. So this one is 25, but these two fractions need an adjustment. So this one has a 2, and this one has a 12. So minus 50 plus 48. So negative 50 plus 48 is negative 2. 25 minus 2 is 23. So then we know that the point P, 5/6, 23 divided by 12 is the point on the graph where what? Can anyone tell us where what happens?
The tangent is horizontal.
Great job. Where the tangent is horizontal. Very good. I would like to look at a word problem. 88. Any questions before we continue? Any questions? Okay, temperature during an illness. So we are given the temperature function of time is negative 0.1 t squared plus 1.2 t and plus 98.6, where t is the temperature in degrees Fahrenheit and t is time in days. So temperature, time in days. Okay, first question. Find the rate of change of the temperature with respect to time. When I'm asked to find the rate of change of temperature with respect to time, what am I really asked to find? The what?
The temperature change over a certain amount of time.
Good, but what am I really asked to determine? Exactly. I'm asked to find. I'm asked to find the. How do we call it?
Derivative.
The derivative. So can anyone give us t prime of t? I'll write it down. Anyone?
Negative 0.2 t plus 1.2.
Great job. That's it. Part B. Excellent. Who was that, Lake?
Yep.
Okay. Part B. Find the temperature at t equals 1.5 days. What am I asked to find? And where do I plug this in? One more time. Find the temperature at t equals 1.5 days.
You plug the 1.5 into the derivative.
One more time. Find the temperature at t equals 1.5. I'm not asked to find the rate of change at t equals 1.5.
Use the original.
In the function itself, yes. T 1.5 negative 0.1 times 1.5 squared plus 1.2 times 1.5 plus 98.6. And I know everyone can do this. I'm just going to plug it in. So negative 0.1 times 1.5 squared plus 1.2 times 1.5 and plus 98.6. Done. I got 100.175 degrees Fahrenheit. Part C. Find the rate of change at t equals 1.5 days. What do I need to do now?
Plug it into the derivative function.
Yes, because I'm asked to find the rate of change, not the temperature, but the rate of change of the temperature. Okay, so negative 0.2 times 1.5 plus 1.2. So I don't need a calculator for this. I'm just lazy. Okay, and then plus 1.2. I got 0.9, but now I need the measurement unit. Last time we talked about this. What is the measurement unit? Since I still have it in my recycle bin. Measurement unit for the difference quotient, for the rate of change, or for the derivative must be a ratio. Dollars per hour, miles per hour, degrees per minute, blah, 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 blah. So,
degrees per day?
Exactly. Degrees Fahrenheit per day. Great job. Good. I have a few minutes. I just want to show one item from 1.6 because I'm not going to be able to finish. I was hoping to, but it is what it is. So 1.6. In 1.6, we're going to look at two rules. One called product rule and one called quotient rule. These have to be remembered. To be remembered. Okay? Very important. Do not try to reinvent anything here. It's too late for us. Okay? So, if I have a product of two functions, and I'll give an example in a minute, that I want to differentiate, there is a specific rule for this. Do not try to do anything else. It's not going to work. The rule is a sum of the first function prime multiplied by the second one plus the first multiplied by the second one prime. And I know I'm down to 5 minutes. As a token of respect, I'll finish in 5 minutes, promise. But I want to show an example. Number 5 on page 154. We are given a function called uppercase f equals 3x to the fourth, and then multiplied by x squared minus 4x. And I know what you will say. Just distribute. Yeah. I will distribute and I get 3x to which power? Brianna, 3x to which power? Brianna, are you with us?
I think she said she was going to look at something.
X to the which power, Zainab?
Six.
Good. And minus 12 and x to which power?
4.
Careful.
6.
Careful.
Wait, what?
If 4 and 2 is 6, 4 and 1 cannot be 6 or 4, right? Good. But this is not what I want. Then I can differentiate this and I'm done. But we don't want to do that. So we want to use the product rule. So I'm going to call this function f, and I'm going to call this function g. So then when I differentiate function uppercase f, I will differentiate 3x to the fourth. Can anyone give us the derivative of 3x to the fourth?
12x to the third.
Excellent. Multiplied by the second function. I just copy it. I'm here now with plus. I copy the first function, which is 3x to the fourth. And can anyone now give us the derivative of x squared minus 4x? And I will put it here in parentheses.
2x minus 4.
That's it. That's it. Yes, and now I still have to distribute. I will distribute. So can anyone distribute this term to these two and this term to these two? So we can finish this up.
12.
12x to which power?
5.
Good. Minus 48x to which power?
To the fourth.
Good. And then plus 6x to which power?
To the fifth.
Good. And then minus 12x to the fourth. And I can combine like terms. The 12 plus the 6, it's 18x to the fifth. And a negative 48 and minus 12 is negative 60x to the fourth. We used